This is Waga. We're going to do another Leetcode question. The question in question is 1015, smallest integer divisible by k, right? So we are given you're given a positive integer k, and you are supposed to find the length of the smallest positive integer n such that n is divisible by k, and n only contains the digit 1, right? So you're given we could look at the examples. You're given k, and the answer is 1 because n 1 divided by 1 is going to be 1. You're given 2, the answer is -1 because there's no possible positive integer that could be divisible by that. And you're given 3, and the answer is 111 because 111 has a length of 3 and is divisible by that, right? So how we would solve this is there's a pretty intuitive way we could use, right? So you're told here that you want the smallest positive integer n such that n is divisible by k, right? So and it only contains the digit 1, right? So if you write all our numbers, if you look at all numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. The first thing you would note is that since all the numbers are made up of ones, right? We're either going to have 1, 11, 111, 1111 in that order. There are some numbers whose multiples can never end up with 1, right? One such number is 2, right? So we could get rid of 2. 2 is not to be considered because there's no possible way that 2 could, any multiple of 2 could end up with a 1, right? The same is true with 4. The same is true with 6, basically all the even numbers, right? So we could get rid of these numbers like so. So we have 1, 3, 5, 7, and 9 to be considered for starters. Candidates. Another number we should consider is 5, right? All possible multiples of 5 end with either 0 or 5, right? So we should get rid of it. But there are possible multiples of 1 that end with 1, right? Like 1 times 1. And also if you multiply 3 by 7, you get 21, which end with a 1, right? So it's possible that further along the line, we could have all ones that end up with 1. 7 times 3 is 21, so it's possible. 9 times 9 is 81, which is also within our realm of possibility, right? So the first thing we would do is we would try and check the modulus. We could get the modulus of the number, and if the modulus of the number, like if the number, we get the number k, right? If k, the number that we're given, and we get the modulus, if we divide it by 10, if it's not among the numbers 1, 3, 7, and 9, we know to discount it because there's no possible way that integer could be divisible by numbers that are all 1, right? So that's the first thing we would do, and then afterwards we would just loop through and check the modulus. If ever we get the modulus of the number, and we start off with 1 and then progressively increase it to 11 and then 111, like so on and so forth, and see that if we ever return return the length after we get the modulus by dividing it. So first things first, we check if we get the modulus of k by 10, if it is not in the possible if the remainder is not among the numbers we discussed, if it's not among 1, 3, 7, and 9, right? So if it's not among one of them, we just return -1, like so, right? So that means that there's no possible way k can be divided. We can get the smallest possible integer only containing ones, right? So the next thing we need to do is we need to start off our number, and we could say number is going to start off as 1, and after that, what we need to do is we need to check. We could also have something length. Okay, we have to spell it out correctly in full. To have length equals 1, and we check while true, so that we can loop through. Or you could say while true, and we say if num modulus by k is going to be 0, what we need to do is return true, right? So we'll start off at 1, of course, and then after that what we need to do is we need to increase the length by 1, and then increase the number. And how we make the number, how we convert 1 into 11 is pretty simple, right? We take num, we multiply it by 10, then we add 1, right? So it will convert 1 into 11, and then 11 into 111, and then 1111, and so on and so forth, right? Instead of it returning true, we're supposed to return the length, right? So we come here and we say length rather than true, right? So in that situation, we convert it, we try to convert it now to submit it. And if we submit it, hopefully it will be accepted this time. Okay, so it has been accepted, right? Since we loop through it's going, the time complexity is going to be O of the time complexity is going to be trying to think about the time complexity. It's going to be O of the structures we create are not, I think, are constant, right? So for the space complexity, it's going to be O of 1 because we only create this k here, which is 4 elements. So the space is going to be straightforward O of 1, but the time complexity is going to be, let's call it O of 1. The time complexity is going to be O of 1, pretty straightforward, and yeah, basically that. Thank you for watching. Subscribe to the channel. I'll see you in the next video.